Alright, here's my test equations. I did the linear versus rotational comparison right there. Moved it over to here, and I just put the rest of the equations right there, including kinetic energy, potential, spring, final equals initial, all that shit. Then I put over here all the equations that were given to us on the first test, which, like V equals V naught AT, delta X equals all that shenanigans, work equals FD, friction equals the normal force times, the coefficient of friction. And then I did the spinning top problem, which is number 9. I threw it in just to help. And I put in the sled problem, which includes all of these equations right here, which are M1 V1 equals M1 plus M2 V2, yada yada yada. If you don't understand this, let me know. The M's do cancel out. These are not their simplified forms, but they do help, because these are the ones that Chalupka is probably going to give us, and you can actually show that you actually did the work on it. Over here, I did the pivot point problems. I'm trying not to do the entire problem so he doesn't think I actually worked it out, but it shows gravity always acts on the center, center of gravity. And this is a good equation. F net minus mg equals 0. As long as there is no motion. Well, no duh. Most time there isn't. Here's another helpful equation. This is for the part where there were, the guy was lazy on the couch. You're moving. So, mass 2, where the mass is put on. Blah, blah, blah. Anyway, I did the banked car slope, and I did this to help out. Make sure the axis is along the acceleration, so the acceleration and gravity, aka the weight, are both on the x and y axis respectively. I put down those little lines in the front are actually little bullets, not negatives, but the sine of theta is prevalent in y for the force of static friction, and the cosine is prevalent in y for the normal force. But it's vice versa when it comes to the x-axis. The sine of theta is prevalent in x for n, and cosine's equivalent for x of the static friction. And then you use angular equations, like Fc equals mv squared r, and, static friction equals v squared over rg. That's actually very good. Very, very good one. Pivot lifting problem. N minus force applied plus mg equals 0. Because, it equals 0. To complete it, multiply the radius by force, rf. And then down here, put a little picture, 2 pi radians equals 360 degrees, delta theta equals s over r. And then over here, right hand rule. I imagine holding r on a plate, so, one sec here. If the r in Star Wars is your r, you want to hold it like this, hence on a plate, and if your force is up, you curl it up, meaning that the force is negative because it's going inside the paper. However, if it's like this, imagine a backwards plate, and if the force is going down, you move it down like this, and the thumb's coming toward you, therefore making it negative. And then back at the very end, it shows that thumb out of paper, positive, thumb into negative, and the sigma of all torque should equal 0. And like I said over here, good luck, and see you guys tomorrow. Good luck.